Hello, this is Tony Nichols, co-founder and CTO of Great Ideas. And in this video on enterprise architecture, we're going to look at the topic of asynchronous messaging, and we're going to use examples from our Trellis Spark framework that focus on Microsoft.NET architecture implemented with C#, Blazor, and Azure. So this video is going to discuss the following questions. What do we mean by asynchronous messaging? How would it apply to you? And what are some of the example technologies that you would have come across so far in your work experience? We're going to have a look at some of the common issues in implementation that we've seen over the years in various projects and applications. And we're going to outline for you a very simple optimal messaging architecture. We're then going to look at a couple of demonstrations to show how this architecture works in practice, both for inbound and outbound messages. And then we'll just quickly summarize with why should you use this approach when building out a messaging solution for your applications and enterprise. So let's start off with a very obvious asynchronous messaging example. So this is something that we probably do every day. So at the top of this diagram, Tony wants to send a test email to Rob. Okay, very, very simple. This is an asynchronous messaging example. Email is one of the most prevalent asynchronous messages that we send. So essentially what's happening as we go through this process is that Tony is signing into his Outlook client. He is writing my message into my Outlook client. So this is locally on my computer, and that goes into my outbox in my Outlook client. And then my Outlook client is attempting to synchronize with a transport layer. In our case, it's Microsoft Exchange. So the message transfers from my outbox into Exchange, and a copy of the message is sent to Exchange, and the original email is actually put in my sent folder. Okay, so the email in my client has not been destroyed, right? It's been copied to Exchange and it's been moved to the sent folder. Then this is where the asynchronicity comes in, because although I have pushed that message from my client to my transport layer at Exchange, that's not happened instantaneously. My Outlook was not frozen while that message was sent between Outlook and Exchange. Now, that message will sit in Exchange until Rob signs into Outlook, and his Outlook client on his computer is going to basically go to Exchange and say, hey, are there any messages for Rob? And if the Exchange transport layer has got messages for Rob, it will then send those messages into Rob's email client, and that message will then be available for Rob to be able to read. So this is a classic example of a asynchronous messaging platform. You can see we have a client that I'm working with synchronously to write emails and to send them, that my client is asynchronously sending those messages to the Exchange transport layer. And then on the recipient side, Rob is also working synchronously with his client, and he is then able to read that message, which has been pulled down asynchronously from Exchange when Rob has actually kicked off his mechanism. So if you were looking at a definition of what do we mean by asynchronous messaging, then essentially what we're talking about is the transfer of data between two actors using some sort of buffering mechanism. And those actors could be people in this example, or they could be applications, or it could be a mixture of people and applications. But essentially, it's the transfer of data between two actors using a buffering mechanism. So we started with email. It's a common format that anybody is familiar with at this point. But when you think about it, messaging is anything. It's SMS, it's Facebook messages, it's Twitter messages, it's LinkedIn, it's Instagram, anything where a person is sending a message to another person. So any of our communication protocols that we use on social media essentially fall under this asynchronous messaging technology. It's about the only one that doesn't is a phone call. So if I actually phone up Rob, then in real time, Rob and I are communicating. But everything else that we use, so for example, email for messaging capabilities and stuff like that, those are examples of messaging technologies that we use on a personal level and also within work content. But if we want to sort of like go a little bit deeper, so let's think about application workflow and think about messaging technologies that are used between applications. So obviously FTP and secure FTP and shared file storage. So essentially what we're doing there is the message is essentially an electronic data file. We're dropping it in some shared file storage. So the actual communication to the FTP store or the shared file store, that's me sending the message. And then at some point in the future, a client can then actually read the message from that data store. Similarly to say emails, there's a whole bunch of what we would describe as message queue technology. So a message queue, again, is a transport layer where essentially message data is put into a queue, and on a first in, first out basis, then a recipient who's actually reading messages from that queue can pull that messages off. So message queues are available from Azure, AWS, Google Cloud Platform, you name it. There are a lot of message queue technologies that are available from cloud providers. Microsoft also has MQ, and you can go out and pick up many different message queuing technologies from all sorts of different vendors. Similar to message queues, but a little bit more advanced, to the idea of service bus or enterprise service bus. And essentially, with the service bus technologies, these are more written for large-scale enterprise electronic data interchange. They provide slightly more sophisticated security and queuing mechanisms than standard message queue technologies. Certainly in the cloud environment, the persistence, the size of the messages, the size of the queues tends to be a little bit higher. And they also implement essentially the idea of a queue, a simple first in, first out, and the option of being able to send a message to a topic, and then multiple clients can subscribe to the same topic. So essentially in the service bus topic solution, the message you send is copied to each of the subscribers of that particular topic. So it's basically you send it to one and it gets written out to many things, and it's up to the clients which topics they subscribe to. So it's like doing a CC, but essentially you aren't, as the sender, in charge of who gets the CC. It's the recipients basically subscribing to a topic that says, okay, I want to hear about topics related to .NET, and everybody then gets the message that you send to the .NET topic. And then on top of that, there are innumerable custom-built solutions where third-party software firms have implemented their own transport mechanism, given different security requirements. And you may even end up building your own custom solution to take data from various data sources and perform validations. So essentially, there is a vast range of technologies and protocols for sharing information asynchronously, and they're very commonly used in application workflow to share information between different applications within the same enterprise, or to actually cross enterprise boundaries and to communicate information and synchronize data across multiple organizations. So all that being said, what are the issues that we see all the time when we look at different implementations of applications? Well, the biggest one is essentially what happens when a developer says, okay, I need to send an email. Part of this workflow, I'm going to send an email to client A, or I'm going to send an email to this customer, is that they start by saying, well, I need to send an email. What's the easiest way to do this? Well, I'll just go to NuGet. I'll download an SMTP library. Okay, great. I've got my SMTP library. Now what I'm going to do is just code sending out an email. So although they're using a shared SMTP library, there's no real code use within the application or within the enterprise, right? Every developer who needs to send an email is essentially coding it themselves in every particular place where they're going to send an email. And a developer or a team within a large-scale project may share and cut and paste code fragments all over the place, or they may even build a common library within that particular project. If you've got 10, 100 applications, you're probably dealing with multiple different SMTP clients, different ways of connecting, different implementations of that same basic functionality. What this means is that you don't really have any standardization in either the implementation or the libraries that are being used by your developers within the enterprise as a whole. And this can cause problems because you may be dealing with a developer who's using an old open source SMTP or POP3 library that's not secure, and on the other hand, in another project, maybe your developer's a little bit more savvy and has got a secure POP3 client and is basically implementing security protocols that should have been implemented in the first place. And then you've got all of that application code aging over time, and then you're dealing with legacy code and solutions and so on. And that can be complex and challenging. So even though the individual implementations are actually fairly simple and straightforward, and a developer looking at the need within a workflow to send out an email is probably saying, well, I can just reuse this SMTP library, or just use this POP3 library, or just use this MQ package, and I'll just write the thing in here and do it. It's like 5 lines of code and we're done. It's not really maximizing code reuse or standardization across the organization as a whole. The other major difficulty with this approach is that every time the developer needs to connect to a third-party service, they've got to basically have the connection information. They've got to know, well, where is this service that I'm connecting to? What's my port? What's my IP addresses? What's my user IDs, passwords, secrets? And all of that information needs to be available to the developer, or at some point written into config files for the application. And then as the number of applications expands, you end up with lots and lots and lots of copies of connection and secret information that you now have an administrative problem of trying to maintain that secret information over time and making sure that that secret information is not leaking out to places where it shouldn't be leaking. And then you've got what, to my mind, is one of the biggest failures with implementation is that because people are just saying, well, I need to send this email out, so I'm going to connect to this email service and send the email, right? Is that what they're doing in the user experience or in the workflow is actually making a synchronous call to the target system and then waiting for the connection to complete and send the email and get the response to the email being sent and then proceeding. So essentially, what you don't have is true asynchronous communication. You've actually got a synchronous step where the developer is forcing the user or the application workflow to wait for the connection to the third-party service to be established and for the information to be sent before they can proceed to the next part of the workflow or the user experience. And again, this is a very common practice. You see this all the time in developer applications where the user is interacting with the screen and the screen hangs for 30 seconds or a minute while an email or a data file is sent to somebody else, and then the user's told, hey, the email was sent, we can get on with our work. So it's a poor user experience, and again, it can significantly slow down workflow and automations. The other thing is that because people have been taking this shortcut approach, they're not typically implementing some common messaging patterns, right? So they're not really doing internal asynchronous buffering of messages. They're not necessarily implementing auto retrial failure circuit breakers, once only delivery, ordered delivery. I mean, a lot of the patterns that we would expect to see in advanced messaging solutions generally aren't implemented by developers when what they're doing is, okay, I've got to send this email from this workflow or put this message on this MQ or this service bus as part of doing this workflow automation. So these are common issues that we see all the time in the implementation. We've got the issue of performance, we've got the issue of the secrets and the administration and all of that overhead, and we've got tons and tons of code in the solution where we've got lots of repetitions of connect to an SMTP server, connect to a POP3 server, send this email, read this email, wait for this to happen. Okay, so if that is not the solution, what is the solution? What should we be looking for in an optimal messaging architecture? So ideally, what we would like to see is something similar to our Outlook Exchange example that we were looking at the start of the video. Ideally, whether or not we're a user or we're part of a workflow automation or whatever, what we would like as our first point of contact is a messaging library that will provide essentially a send and a read operation. So we shouldn't really care whether the data is going over email or MQ or a service bus or it's an SFTP drop. Why should we care about the transport protocol? So at the point where I want to send data from me to somebody else, all I really want to do is have a synchronous send read operation that I can put the data that I want to transmit into a local table in my data at rest record storage. So here is where my buffering occurs. So I want to send a message, let's say it's got 100 bytes of data. I'm going to basically use my messaging library to synchronously put that data into a local table in my data at rest storage. So this would be my message queue table, and that would be buffered. And that local call, that synchronous transfer of information, securely takes the data from my user or my workflow application, puts it into a buffer table in my local data at rest storage. Now, I know that my local data at rest storage must be there, because if it wasn't, none of my applications would be working. And that simple synchronous request is going to execute in microseconds because it's all local. It's all going to my local database. It must be there, it must be connected, and it will transfer very quickly. So that synchronous communication of putting the data into the message queue table is not going to impact my user experience or my workflow automation. This is something that's going to be sub-millisecond. It's going to be really, really fast. And I would know that my data has been transferred successfully to that buffering table. Now, the second part of my message architecture is my messaging service, this asynchronous service that's running in the background. And what that asynchronous service is doing is it is taking the buffered messages out of my local table, which must exist and must be easily available to my local messaging service. Because again, if my data at rest record storage was not available, my messaging services would not be running at all, or would not be able to run at all. So my messaging service in this particular case is going to read a message from my local table, and it will then be responsible for making an asynchronous connection to my third-party transport service, and it will push that message into the third-party transfer service, and it will be responsible for all of the message patterns. Let's make sure that we've got non-repudiation. Let's make sure that the message was actually sent to the transport service. Let's make sure that if it fails, that we have retries, etc. So we can centralize all of the communication from our local message queue buffering table to our third-party transport through a single centralized messaging service. And this is the thing that's going to do the connections. So all of the secrets are in one place. All of the standard communication protocols are in one place. If I need to layer over this some more security or encryption mechanisms, it's all guaranteed to be in one place. So the ideal solution here, the optimal messaging architecture we want to achieve within our organization, is simply a synchronous send read to a local message buffer, an asynchronous send read to remote third-party transport services, that messaging service provides a central focus of control and standardization across the enterprise, so it makes it easy to maintain over time, and ideally it should be able to transport data over any protocol. So although my agreement with my third party may be send me an email to this email address today, if 5 years from now they decide they want to do it through a service bus with a different encryption layer, then why should I have to change my code? Why should I not be able to say, well, okay, I'm still sending the same data, but the transport, instead of being through a message queue that's going to basically send this data as an email, the message queue is now going to be reconfigured to send that data using a service bus topic. Right? And that way, I don't have to recode my sender because the sender doesn't care. The sender just knows it wants to send this sort of data to this message queue, and then the messaging service can then make the decision, is this over an email transport or a service bus transport or whatever. So essentially, this messaging architecture gives us the ability to build something that's going to be future-proof in very many ways. So for our first demonstration, we're going to look at the outbound message flow. So that is from our user or workflow, sending the message through the synchronous solution to the pool buffer in the local database. And then from there, the messaging service picking that up, making a connection to my outbound third-party transport layer. So for the purpose of this demonstration and the next, we need a sample message queue that we can bounce messages off. So in this demonstration, we're going to be testing the outbound message queue, and in the second demonstration, we're going to be testing the inbound message queue. So what I've done is I've gone into Azure, I've created a storage account called Trellis Spark Demo, and then within that storage account, I've created a queue called Test Message Queue. So very simple. I just want a message queue that I can use to bounce messages off for this demonstration. So in Trellis Spark, I'm going to configure access to that queue for both inbound and outbound messaging. So the way I do this inside Trellis Spark is I create a window service. In this case, I've got core generic services. And then on that generic service, I attach the message queues. So here you can see I've got a marketing campaigns, I've got inbound and outbound message queues. So for the purpose of this demonstration, the test message queue I'm using to test the outbound functionality is this test outbound Azure MQ. Okay, so if I'm looking at the message queue, what do I see? Well, I need a name that I'm going to use within the application to be able to send messages to this queue or receive messages from the queue. And it's the name that's important here, right? I want a unique message queue name for each of my message queues. I then need to decide what the message queue type is. And you can see this is a subform where I've got essentially a whole range of out-of-box message types available within Trellis Spark. So I'm using the simplest solution, which is an Azure storage queue, and I've configured it for outbound traffic. Now, one thing that is used in the background is this message queue GUID, but for the purpose of this demonstration, we don't really need to know what it is. When I select the queue type, I will also be given essentially a set of subform fields, and in this case, I need to know what the storage key is to allow me to access the queue, what the name of the Azure storage is, and what the name of the Azure queue is. So in this case, I've basically got a key, some storage, and a queue. The storage key is going to be deleted at the end of this video, so it doesn't really matter that it's exposed here. Okay, so I mean, ideally, you'd never expose your storage keys to people, but as I say, it's a temporary thing. It's in my demo environment. It's going to be deleted in a minute. So now that I've actually created my Azure storage queue and I've configured it within the application, now let's actually see the interesting part of the demonstration, the bit where we actually send a message to this queue. So what I've done is I've configured a command here called test outbound, which is going to basically send a message to this outbound message queue. So let's see how this is working. So this test outbound is connected to my example API. So this is part of the open source functionality that we give you all to have a look at and see how we actually build things within Trellis Spark. And you can see that as we come into our test API, we're going to basically establish a connection to our data at rest. This is calling our system of record. We're decoding the command data that's being passed in, and then we're looking at the command name. And in this particular case, the command name is outbound. So what I'm going to do here is I can pull the outbound queue ID and I can create essentially an outbound message information. So this outbound message information contains a set of fields that would be considered generic depending on what sort of information are we actually trying to send out of the system. So for example, I want to make sure that each message is uniquely identified, so they're all given their own unique message GUID. I want to know which message queue name I'm sending to. So in this case, this message queue name, test outbound Azure MQ, corresponds to that outbound message queue that I set up and showed you in the configuration. Now what I've got is a set of 5 fields that basically define the content of the message I'm trying to send. So if you were thinking of this as an email, it would be the subject, the content, what the format is, who my sender is, who my recipient is. So sender and recipient could be email addresses, they could be any textual description that makes sense in the context of what are we attempting to do here, and what data are we attempting to send. And depending on the actual queue this is sent to, some or all of that information may be used or combined to actually send the message to the appropriate recipient. So let's step through this quickly. Now, what's happening here is we're actually going to send the message to the database. So let's go and have a look at the database and see what we've got there. So if I open up my database, I can see that I now have a new record in my database where the sender was the outbound, recipient is the inbound, the subject is Azure Storage Test. If I open that up, my body content is test data, and you see here that the GUID here, 40, corresponds to the same GUID I have here. So what's happened so far is that my application has added a row to a local table in my data at rest record storage, in this case in messages. Now obviously this message table could be in my main database for my record storage, or it could be in a completely separate database. It doesn't really matter, right? I've basically configured a simple stored procedure that takes the information that I gave it from the API, and I wrote a single record into my buffer message table. So this is my buffering mechanism here. So we're going to need to keep our eye on that and decide where it goes in a minute. Okay, so if we just allow this to finish executing, and we're back here. So we've now written one message into our buffer table. Has it arrived in the message queue yet? Well, let's go and have a look at the message queue. So here is my test message queue. I can refresh here and you can see I have no results. So far, all that we have done is we have written a single row into our database table here. And that's it. That's all that's happened. Our application workflow, wherever that workflow existed, has written one row of data in here. And that's important to note, right? Because I'm not limited to sending stuff from C#. I could have used T-SQL to write the row directly in here. I could have used any mechanism where I can access my data at rest to say, go and write a record into my dim messages table. And you'll see in some of the examples when we go into the more detailed deep dive workshops on inbound and outbound message flow communications that we can use this for synchronization. So for example, a stored procedure could update our instances table, and a trigger on that instances table or on associated lookup table could then write a row into our messages table. So we can use this as a mechanism for synchronizing data out to other applications. And there are no limitations, essentially. As long as I can write a row of data into this table, I can access messaging services. So let's have a look at now the next step. How does it get out of this buffer table to the application, in this particular case, Azure Services? One thing to note about this process so far is that my workflow completed and I am back. My user experience can now be used for whatever the user is doing. And this is buffered. This is completely decoupled and asynchronous between this buffering table and now my external storage. So let's have a look at how it's moved from my buffering table to my external storage. So in this particular example, we're going to use a Windows service, so WS generic, to actually send and read messages to the Azure storage queue. So let's have a look at how this works. I'm just going to kick off this function. Okay, so on the service, we had a number of message queue set up that we're not really interested in working through at the moment. So I'm going to ignore this one because this is the marketing campaigns queue. And we'll ignore this one because this is the test inbound. So we'll be looking at this in the next demonstration. So this is the message queue that I actually want to process the outbound message. So let's see how this processing works. So if we quickly step over this, what we are doing is we are initializing a connection to messaging services. And here we're going to go into process messages. So this is essentially where we're going to get interested in how does this particular function actually work. So what process messages is going to do is it needs to establish a specific implementation of the messaging base class. So what we're doing as we go down here is we are trying to establish what sort of message queue are we dealing with. So if we look at the queue XML, you can see here that it's pulled our queue name, test outbound Azure MQ. So that's what it's been given. It knows that it's an outbound message queue it's trying to connect to. It knows that it's an Azure storage queue. So it's now going to be expecting these fields here that tell it how to actually connect securely to that queue. So what's happening here is that we're going through and we're extracting the information from the XML file. And at this point, what we're doing is we're establishing that the messaging is implemented by an Azure storage queue. So if you look here, we have a messaging base class that basically provides our definitions for send and read. And then depending upon what type of storage queue we're dealing with, we have implemented a set of detailed implementations. So this is how you connect to an Azure storage queue. This is how you connect to an Azure service bus. This is how you connect to Event Hub, and so on. So there's a whole bunch of things that we just provide out of box for you to play with, using most common cloud platforms and email servers. And essentially, this is giving you a jump start into your implementations. So let's sort of step through this now and see how this is working. So the first thing it's going to do is actually pluck the storage name, queue name, and key. It's going to establish a connection to the endpoint and create if it doesn't exist. It's a message queue. So at this point, I have now created a Azure storage queue client ready to send messages to. So let's sort of move on now and see what's going on next. So as you can see here, we have a lot of different ways of which we would create different clients, all of which end up implementing our messaging function here. So these are all basically implementing our messaging base class. And at the end of this process, we have decided what sort of message queue we're dealing with and how do we successfully connect to that queue. And at this point, my messaging object now has an appropriate class assigned to it. So here, what we're going to do is we're going to start by attempting to read the first message on the designated messaging queue. So if I look at my message info at this point, you'll see that all I really know is what my message queue name is. I don't have a queue GUID, and all of this other stuff is basically nulled out. So I'm going to attempt to read the latest message off the queue. And if I look at my message info now, you'll see that I've basically pulled off the information for that message that we just added in the first part of the demonstration. So I have outbound queue, inbound queue, queue name is a test outbound Azure MQ. Here's my test data here. Here's my message GUID. You can see the correlation between the two GUIDs here. So at this point, I've read the message off the buffering table. Given that I actually got no errors, I'm going to check to make sure that I got a valid message GUID. So I have a message that I actually now need to send. So here what I'm going to do is I'm going to default my info to an empty result and default my result to be success. And at this point, I'm going to actually attempt to send the message to the outbound message queue. So at this point, this thing is set to an Azure storage queue. The connection has been established. Everything is there. Here is the messaging information that I want to send. And if I step into this now, you can see that I'm now in my Azure Storage Queue implementation, and I'm using my queue client to send a message asynchronously. And in this particular simple example, all I need to do is put the body content as the message on the MQ. Okay, so an Azure Storage Queue is very simple. It just wants some content, so I'm just going to give it the body content. this is the place where I now want to centralize and do all sorts of really cool stuff. So for example, this implementation and this demonstration, all we're going to do is queue the body content. But in a future video, what we're going to look at is, well, okay, what if I want to consolidate the sender, the recipient, the subject, and the body content into, say, XML and send that? What if I've got that XML and now I want to do some DLP, right? So I want to make sure that I don't have a data loss prevention issue, right? So I'm not sending out credit card information. What happens if I want to take that body content and compress it, or if I want to take it and encrypt it? There are lots of other things that I can do in this central window service that would apply to all messages sent via a particular channel or a particular set of configuration parameters. So as I say, we'll do a complete video on hardening our message. So at this point, all we're doing is sending a very simple body content. We're going to send the raw text, and that's all we're going to use for this level of demonstration. So at this point, when I do this, the message has been sent to the queue. So let's have a look at the queue. So if I refresh my queue, you can see that my message data has been here, and here is the GUID. Note that this GUID is the GUID that's been assigned by Azure, and it's got nothing to do with the GUIDs that I'm sending for the message IDs here. Okay, so these are not the GUIDs for the messages that we've got here. Right? So in this particular case, I've added my message to the MQ. Story's not stopped though, right? So I've put the message on the queue. If I go and have a look at my database and execute this again, you can see that I still have the message sat in the buffer, waiting to find out what happened on the queue. So let's go and get rid of the message off the queue. So let's go and see how this processing works. So if I step off here, it's been sent to the queue. Did it send successfully? Yeah, my error message is empty. Yes, it must have sent successfully. Great. So at this point, I need to move it from the buffering queue. And I do that using a GI processed message stored procedure. And I pass it the result, which should be success because it was correctly moved. And now when I execute this stored procedure and check the error message, which is successful, I should now have moved my message from my buffer into my history table. So let's go and have a quick look at that. So you can see the message has moved from here. It's now sat down here. And I've tagged the result on this particular message as being a success. Yay, winner. Okay. Now, obviously, if the result is not equal to success, the message is transferred into our message failures table, and we can figure out what's going on there. Now, again, when we're looking at the outbound processing, there's so much we can implement in that Windows service. So we talked about the DLP, we talked about compression, encryption, but there are so many other patterns that we might want to put in here, right? So guaranteed delivery. So what happens if it fails? Do you want to implement an automated retry pattern, a circuit breaker pattern, and so on? And what we can do on the outbound message justifies its own detailed video, and we'll be doing that later in this course. In this second demonstration, we're going to be looking at the inbound messaging flow. So here, somebody has put some information into a third-party messaging service. Our messaging services are asynchronously going to transfer that information from the third-party transport into our local message queue table in our local storage, and then our application workflow is going to basically make a synchronous read from our local message queue table to retrieve that message and process it. So at the end of our first demonstration, we had successfully written our test message into our test message queue. Here it is. Okay, so it's there, it's ready for us to pull into the solution. So let's have a look at how that's going to work. So the first thing is the actual asynchronous processing related to this message. The first demonstration, we started with the API, and then we went to the synchronous service to actually push the message from the message buffer into the Windows service. This time around, obviously, it goes the other way. So the first thing that's going to execute is our generic Windows service. So let's actually have a look at that executing. So I'm going to start my generic service off. So once again, I can ignore my marketing campaigns. And now I've actually got to the queue that I'm interested in, the test inbound Azure MQ. So at this point, what we're going to do is we're going to say, hey, I need to process messages. This time I'm processing messages on my test inbound MQ. So let's see how that works. Okay, so again, the process messages. First thing it's going to try and figure out is what sort of queue am I dealing with here. So I've got a base class implementation. So I've got a base class interface. What implementation do I need to choose? So the first thing it's doing is basically looking at the queue definition again. And this time it's a different queue, right? This is a different queue GUID. It's a different message queue name. This is my test inbound Azure MQ. It's still an Azure storage queue. This time my direction is inbound processing, but my storage connection information is basically the same. It's still the same queue I'm trying to connect to. Okay, so let's sort of step through, see what's going on here. So again, first thing it's going to do is set up the direction, figure out the connection information, and figure out what specific implementation of the message client I need. Again, it's going to be an Azure storage queue, and it's going to basically set that up for me. And now it's saying, okay, great. I've got my client, it's connected to my storage queue. Is it outbound? Well, no, it's not outbound, it's going to be inbound. So we go to the inbound processing. And for the inbound processing, we're going to start by queuing up a message. And what we're going to do is we're now going to use our external messaging client to attempt to read the next message off our Azure storage queue. So let's step into that, see how that's working. So here I've got my message information. I'm just basically initializing my message data. So I've got a nice simple empty message info record now. And then I'm using my queue client to actually receive messages from my Azure storage queue. I need to check to see, did I actually get any? Okay, so I did. So I'm going to give it a new internal GUID to play with. The only thing that I'm actually going to pull from my messages, my retrieved message, is the message text. Right, so this is where I pull my body content back into my message info. And then here, I'm going to remove the message from the Azure storage queue. Okay, that's it. Just pulled one message off. So if I look at my message info now, you can see I've got a unique message queue, GUID, and I've got my body content, but I didn't put anything in the body format, the sender, recipient. I'm just using a simple body content bounce here. If you remember from the first thing, I basically just ignored the other fields for the purpose of this simple demonstration. Just simple data in, simple data out. Now, here we're going to basically be doing a whole bunch of other potential processing. So I could just have a simple generic process that reads the content and then just pushes it through in the way we're seeing here. I could also and should also be doing data validation, right? So for example, if I'm pulling information in, I should be doing encryption, so decrypting the data, maybe decompressing the data. Once I've got decompressed data, I should be checking to see the validation, the business rules, and all of that other good stuff. So we're going to be doing another video specifically on inbound message processing that looks at those particular topics. So how do I actually validate data coming into my system? How do I deal with compression and encryption of data flowing into my system? Am I going to push it into my data migration tables, or am I actually going to apply the changes directly into workflow and push it through into other API functionality? But at the point where the generic service is asynchronously working with the storage medium, then I'm going to want to apply generic stuff like decryption, encryption, compression, decompression. So there's basically a place where I can centralize all of that functionality within my solution as a whole. So now that I've got my message here, if I go and have a look at my message queue, what you should see is the message is now gone, right? I have read the message. But if I go and have a look at my buffering tables, you'll see at this point that the message has not actually been added to the queue yet. Okay, so let's go through and see how the message ends up in the buffering table. Okay, so if I step through here, so I've got a message. The message is successfully read. If I got an error message, it would show up here. So what I want to do now is I'm going to add the message queue name into my new message so I know which message queue I want to put this data on in my message buffer. So this is basically adding the test inbound queue to my new message data. So here when I look at my new message data, I've added this value in here, right? So this is the value I got back from reading the information off the Azure storage queue. This was generated automatically, as part of that read process. This is where this message is going. Okay, so this message GUID here, 078, is the message GUID that's going to be tagged onto the buffer when this thing comes in. But this message GUID here, 04EE, is basically the GUID that was originally generated for this message in the first demo. So what's happening now is, again, I'm going to go through the send message processing and actually put that message onto the appropriate queue. So let's go through that processing. And then assuming that the send worked successfully, I'm good. And I can see whether there's another message to read. So here, there are no messages to read. And I'm basically dropping out of my loop and I'm done. So if I go and have a look at my database now, you'll see I have a new message here. So this was my 07 GUID that came from the generic service that tagged a new message GUID onto it. Here is the queue GUID that correlates to my inbound message queue. And here is the actual body content that we've read there, right? So the 40EE3. So here I have successfully read the message off the Azure Storage queue and put it into my buffering table. So at this point, my workflow, whatever workflow I've got, whether it's T-SQL, whether it's C#, whether it's got a logic, it doesn't really matter, okay? All I now have is I have asynchronously moved the message off my Azure Storage queue into my internal message buffer table. So let's see how we might pick that up. So if I go back to my service definition and go and find my inbound Azure MQ here, what I want to do now is I want to test the inbound processing. So I'm going to click here to test inbound. And you'll see I come into my API again. So let's step through the API. So again, I'm establishing a connection to my database, pulling out my command data, checking my commands. In this case, it's an inbound message test that I'm trying to figure out what's going on. I'm telling it to look for the message queue name test inbound Azure MQ. And now let's actually have a look at how we read the inbound messages. So at this point, we've executed read message. We've got our inbound message coming in, and you can see that we got our test data that we retrieved from the Azure Storage queue. We have the GUID that was assigned by the generic storage. We know which queue we read this message from, but the other fields, the body field and the recipient, sender, and subject are all blank. So in this particular case, all we were attempting to do was bounce our test data to the Azure Storage queue and then read it back. And all we've done at this point is read the message back. So if we go back and have a look at the queue at this point, all we have really done here is we have read this message back from the queue, but we have not yet removed it from the queue. Okay, and this is an important point, right? Within our actual workflow, we need a mechanism for reading the message content off the queue non-destructively so that we can then process it. So if we look at this example code now, you can see we've read the message from the queue and we're just hitting the break. So we've left the message on the queue. So one thing that we would want to do to improve this example is we would actually want to go in and process the message. So if we look at the script, for example, in the generic, you can see here we want to basically say, well, look, we've processed the message, that was good, let's move the message. So let's take this code and add it to our example and run the process again. So now I've added some dequeuing code after the read message to basically indicate that the message has been successfully processed. So in this case, I'm going to assume that I've read the message, that I've processed the message, and now I can essentially dequeue it. So let's have a look at what this looks like in execution. So I'm going to test inbound again. Execute my connection. So I've read my message, and as you can see, it's still the 40EE because it was not dequeued in the last part of the demonstration. And now if I go and have a look in my database, we can see that it was dequeued. Now, one thing to note on the history and failures is that we are not storing the body content. And again, this is an implementation decision that we were making when we were looking at this with a number of our clients, in that although it was useful to know that this sender sent this message and what the subject was, we didn't want to preserve the content because that basically was providing a bunch of confidential information that our clients didn't really need to see. So one of the things that you need to think about with your history and failures table is how much data do you actually want to preserve from the buffer into the history and failures table. And be aware, right, that you can set different permissions for different people and different types of users, and that the history and failures can even be in different databases. So when you're thinking about how much of the message information you actually want to track through these logging tables, it's up to you to make a decision on what sort of complexity, what level of information, if any, do you actually want to track. And for how long do you want to track it? So, for example, you might want to maintain message history for a week and failures for a month. So one of the things that you also need to think about from an audit perspective is how long do you actually need to retain any of the logging information in the message history and message failures. So again, from an architectural perspective, you need all of the data obviously in the message buffer, but you don't need all of the data basically in the logging tables. Question really is to say is what are you trying to basically convey in the logging table? So you're just basically just trying to track the fact that A sent a message to B and it worked, or that A sent a message to B and it failed because. So that was the compromise that we chose. But again, your implementation doesn't have to be our implementation. You can do something slightly different here, right? But from an architectural perspective, the thing that you really need to take away from this conversation is that logging success and failure is again a process that is completely up to you from an implementation perspective. Take as much information as you need, but not more than you need. So don't pull down confidential message bodies into your logging tables if you don't need them. And then the final point to make, and again, we just want to reiterate this, right, is that there is a difference between reading the message and pulling it off the queue. So you might read the message but be unable to complete the processing of the message, in which case you might want to leave it on the queue. Or you read the message and the processing fails, in which case you move it to the failures table with a result that says why it failed. Okay, so there's all sorts of different things that you need to think about when you're processing these inbound messages at the point where you're actually engaged in the workflow in terms of data validation. Did it work? Did it not work? Was the contingent processing that succeeded or failed? And then when I move that message from my internal message buffer into my logging tables, what do I want to say about that processing? Did it work or did it fail? And if it failed, what happened? So in this particular case, we've hard-coded the input strings to success, but it may not have been successful. It may have failed for reason X or reason Y, in which case basically put your failure reason into the input string and then the result will be recorded into the failures table in our implementation. So hopefully that gives you a sense of generic inbound processing and all of the other entry points where you're going to need in the inbound processing to do things. So for example, things like encryption, compression, make total sense to put those into the generic service so that any inbound message is potentially encrypted and compressed. So let's imply decompression and decryption at that point. And then when you get into the API of your workflow where you're actually trying to process the message, then that makes sense to maybe do some validation, do some follow-on processing and so on. So this is the point in this API, in the actual workflow, where you decide what you're going to do with the message, how you're going to validate the message, and then record whether it was a success or a failure. One thing to note is that although lots of people can send messages to the same message queue, ideally you should only have one reader reading from the message queue. So that's why this pattern works, right? There's only one API workflow that's reading a message, and it's then processing the message and then deciding the end result of processing that message. We do not recommend that you attach multiple different readers to the same message queue, right? Because then the results can be undefined. And if you are going to do that, then you're probably going to want to alter the read message definition so that as soon as one of your processes goes to the message queue buffer to read the message, that only that process gets that message off the queue and it's then removed. So if you are going to set up a situation where you've got multiple readers reading the same queue for some sort of horizontal or vertical scaling capacity, then you're going to need to add some additional functionality in the read message to make sure that only one queue at a time is reading messages from the queue. It is possible to set up for multiple readers. Again, we will cover that in the separate inbound messaging video. So let's summarize what we've talked about in this tutorial and figure out why we should use this approach. The bottom line is, whatever you do, you are going to need a mechanism for asynchronous data transport. There are very few applications and enterprises now that don't in some way transport data to or from other third-party systems. So one thing that's really cool about this approach is that it can be used as an enterprise-level standard mechanism for all of the transport protocols supported by your enterprise. And because you've centralized it in this one standard mechanism, you now have a central point of control for how data moves between your applications and any other third-party applications, whether they're within your existing enterprise or whether or not they're with third parties. So because you've got this centralized point of control, you've now got a point where all of the connection and secret information can be consolidated and maintained. And that secret information is not then distributed to all of the developers that exist in your organization, right? There's just one point where those secrets actually need to be maintained, one set of people that are in charge of secure transport of information between your applications and the rest of the world. And as we've discussed, because again we have this central point of control, we can easily extend that central point of control to include any of the sophisticated messaging patterns that we might want to build for advanced EDI systems. So if we're going to implement, for example, non-repudiation, if we want to implement some secure encryption patterns, we can put all of that in the one central point of control. And we can change our messaging patterns and we can change our transport protocols over time without having to go back and maintain all of the individual application workflows where we're actually trying to send data. So if all we really want to do is we're still sending the same data, but it's a different pattern with a different security protocol, then great, we just repoint the MQ to a different messaging pattern and we're done. We don't have to go back and rebuild and retest the workflow application that's actually transmitting or receiving the data. The other thing is, the whole point of this approach is that we are going to make sure that all messaging is properly buffered, and that way we are going to make sure that we are not causing delays in our user experience or workflow because the target transport layer is either unavailable or unresponsive.
To learn more about Great Ideas products and solutions, visit greatideas.com. That's great ideas with a Z.com. Thanks.